Good morning, Thursday, February 10th. Again, this is for ACA. Oh, is it February? It's March. LOL. Let's fix that real quick. March 10th. So please grab your homework, get it out so we can check and complete the warm-up. Here is that warm-up, pause, and play for when you're ready to go. Okay, it says write and solve the equation to find the missing angle measure, then classify the triangle by its sides. So is it scalene, isosceles, or equilateral? And then by its angles, acute, right, or obtuse. Now, yesterday we learned that the three angles of a triangle, 1, 2, and 3, always add up to 180. So that equation, it might be in a different order, but it should look something like 112 plus 40 plus x is equal to 180. When you combine 112 and 140, you should get 152. Subtract that from 180 to get 28 degrees. Very good. Okay, so if this guy right here is 28 degrees, to classify, ooh, that was a bit too big, 28 degrees. If I'm classifying by its angles, cover up the two acute. Here's an acute. Here's an acute. That third one is obtuse. And then looking at the side lengths, they gave me side lengths on this one, 14, 25, and 17. None of those are the same, so it's going to be scalene. Okay, I would also know since all three of the angle measures are different, the sides are all going to measure different as well. So again, let's unveil obtuse, scalene. Oopsies, that's spelled wrong. So many mistakes. We're getting it figured out though. There we go. Alrighty. Okay. Homework questions, pause and ask your teacher. They might be able to help you out. If you still have questions, please come to tutorials. All right, here we go, rocking and rolling. Continuing on. Today we're talking more about the side and angle relationships of triangles. We sort of mentioned yesterday, like if all the angles are the same, all the sides are going to be the same length, and we're just going to look at that a little bit more. Okay, starting with this basic triangle, if you have like 3 different colors, it'd be super helpful. Let's start with naming this triangle. So I'm going to call this triangle A, B, C. Okay, you might see that written as triangle A, B, C. It tells you the 3 vertices. Okay, so we can label a triangle by its vertices, and then with that, we can also name the sides. So let's start with angle or side A. I'm going to go back and use some different colors. A, let's do B in red and C in green. A, B, C. Now, we can name different sides. So this side right here, I'm going to put it in blue. This side right here, we can name it in 2 ways. The first way is with the angle that it opens up, or that opens it up. So like this side is controlled by this angle because it's opening it up. It's controlled by this angle right here. So we could call this side A, or we can name it by using the 2 endpoints. We could also say that this is called side BC. Okay, because those 2, B and C, are the endpoints of that triangle. Okay, let me do another one just so you can see. The one on the bottom, this one right here, we can name it 2 ways. The angle that controls it is the one directly across. I always drive these arrows. This is called side B because angle B controls it. Or you could also say the 2 endpoints. So side A, C. You could also say CA. Doesn't matter the order. I'll tend to do alphabetical, but that really doesn't matter. Okay, and lastly but not least is this one over here. Okay, the angle that controls it, I always do like a dotted line. It's not either of the endpoints, it's the one that's across from it. This is going to be side C. Again, you can also name it by its 2 endpoints, side A, B. If you need to pause and catch up, please do so. Okay? So, moving right along, we're going to first look at an isosceles triangle. An isosceles triangle means that there's 2 equal sides or 2 congruent sides. Again, in an isosceles triangle, the angles, so let's pause. Before we get into these fill in the blanks. Two equal sides. If I'm looking at this triangle, let's call it, again, let's do like ABC. Why not? In triangle ABC, if I had to guess, I would say that side AB and side BC, using those endpoints, those are the two congruent sides. So I'm going to mark them with those tick marks. Okay? I would visually be able to say that bottom one is the shorter one, so it's not the same length. Okay? So what we just talked about is that the angle opposite of each side is the one that controls it. So if I was doing this side right here, the angle that controls it is the one that's across from it. So this angle, angle A, is the one that controls that blue side. The angle that controls this side is the one that is across from it. So angle C. It's basically the angle that doesn't touch it. So on this red side, angle A and angle B touch the red one. So the one that's not touching it, angle C, is the one that controls it. It opens up to it. All right, so angle C controls the red, angle A controls the B. So in an isosceles triangle, there's a really cool thing. So because two of the sides are the same, the angles that are opposite of the two congruent sides, those angles are going to be congruent. So let's go back to that. The angles opposite the two congruent sides, so the angle opposite this blue, angle A, and the angle opposite the red, angle C, those two angles are going to be congruent. Okay, so the way that we can write that, like we're not going to write that in sentences always, there's like math speak that we can write. We are going to say that I'm going to write this, the measure of angle A. Again, the way to read that, the measure of angle A is equal to the measure of angle B. Again, the way you read that, the measure of angle B. I don't know either one, but because the lengths of those sides are the same, the angles are going to be the same as well. And we can use this knowledge to help us write and solve equations. And I'll show you what I mean. I'm going to do one with you, and then I'm going to let you do one on your own. Okay, so down here, it says to find the values of x and y in the triangles below. Okay, so first solving for y, let's break it down. Okay, I see y is right here, and that appears to be talking about a side length. Okay, so that's a side length. I see these two tick marks. There's one here, one there. That means those two sides are the same. So, okay, so that side is equal to that side, and this, so that means that this should be equal to this. Now, I can use that to write an equation, okay? If those are the same thing, if those two sides are equal, I could write that y minus 2, this side over here, is equal to 7 on the other side. And I want to solve for the value of y. So it's an equation that I've just written. Okay, I'm going to split it, and then I'm going to get y by itself. So I'm going to add 2 to this side. I'm going to add 2 to this side. I'm going to solve that. Y is going to equal to 9. So I could say y, this side length, is equal to 9. Okay. Again, if you want to make a little note, side RS has to be equal to side ST. And that's how I wrote that equation. Okay. Solving for x. Okay, x is talking about right here. And that is because it's inside the triangle in that corner, that means it's talking about the angle. Okay, what do I know about this angle? I'm going to clear this off again. Okay, I know that this is an isosceles triangle, so I know that the sides are the same. Ooh, but we just said that the angles that are opposite. So let's figure out which angles are opposites. So looking at this side is controlled by the angle across from it. This angle right here, that's 7x. The side ST is controlled by the angle across from it, side 35. So what that means is angle R, the measure of angle R, is equal to the measure of angle T. So that means the measure of angle R, it says, is 35, is equal to 7x. And hey, look, I've got myself another equation. To solve for x, I need to undo what's happening. I see that they are getting multiplied, so I undo with division. x is equal to 5. Okay, again, that's not saying what the measure of the angle, that's not 5 degrees, but x is 5, and I use that to help me solve. So what I want you to try is this next problem. Pause and play when you're ready. Okay, so again, we're solving for y. Y, I always like to separate the sides and the angles. Y is talking about this right here. It's on the outside. It's on the side, so it's talking about the side. This side, ooh, I see a tick mark. I see a tick mark. Those two sides, side GH is equal to side GK. So y plus 3 is equal to 10. Let's solve. Y is equal to 7. Hopefully you got that. Okay, how can we solve for x? X is talking about this angle right here. Let's do some investigations. Okay, those two congruent sides. This side is controlled by the angle opposite, that 12x, and this side right here is controlled by the one opposite of this. So I could say that the measure of angle K is equal to the measure of angle H. The measure of angle K is 72 is equal to 12x. To get x by itself, we divide by 12, divide by 12. Hopefully you get that x is equal to 6. Okay? Moving on. Okay, talking about equilateral. Next page. Equilateral means all sides equal. Okay, so let's go ahead and mark that on this triangle. They look equal as well. So I'm going to do 3 tick marks because I like having fun. 1, 2, 3, 1, 2, 3, 1, 2, 3. Again, I'm using the same amount on all of them because all of the sides are equal. Okay, now this is the problem we looked at yesterday. So hopefully maybe this is the second time you're hearing this and it can help settle it in a little bit more. Okay, so we are saying that if all the sides are equal, we want to look at the angles. If all sides are equal, that's also going to mean that all angles are equal. Okay, so we could say, we could call it PQR if we really wanted to. Okay, but angle P, let's label it as X, that's X degrees. And if that angle is the same, like if that side is the same, that means that angle should be the same as this angle is the same as this angle. Okay, all of them should be the same. I'm going to erase that a little bit. It's a little too much. Okay, so that means that this should be the same measure and this should be the same measure. All of them, even if it's X, even if they're different angles, they all measure the same thing. So we could say that X plus X plus X is equal to 180 because we know that about all triangles. Again, I can rewrite X plus X plus X. That's the same as saying there's 3 X's is equal to 180. Divide both sides by 3. X is equal to 60. Okay, so this is true for all equilateral triangles. This is true for all, every single one, all equilateral triangles. Okay, in an equilateral triangle, all 3 angles are equal. Okay, they're all congruent. It says congruent. They're all congruent, they are all equal. And they will always measure 60 degrees. And again, this is true for all equilateral triangles. Because they're equilateral triangles, and because all the angles are the same, we could also, there's another fancy word, we can say they are equiangular. Say that word. Equiangular, which means equal angles. Okay? We can use this to help us solve some spicy problems. Okay? I'm going to switch it up. I'm going to do this one over here. It's a little spicier, so I wanted to do one with you. And then I'll give you like the not so bad one. Okay, so solving for y. I see that these triangles are equilateral because there's those tick marks mark that they're all the same sides. I need to find the value of y. Y, is it talking about a side or an angle? It's talking about a side since it's on that side piece. It's on the outside of the triangle. That should be the same as this over here. So I can write that 3 1/3 is equal to y plus 1 1/2 yards. Okay? Spicy, spicy. To get y by itself, oh, we still subtract, but we're subtracting 1/2. It's spicy because it's a fraction. Oopsies. Minus 1 1/2. Okay? That will cancel out, and I'll be left with y. Now, over here. When I subtract fractions, there's something special. I can't subtract them as they are. I need to subtract them with a common denominator. So, common denominator with 3 and 2 would be 6. So we're going to change them both to 6's. To go from 1/3 to 1/6, I multiplied them both by 2. So I got to do times 2 on the top as well. So that's 2 6. To go from 1/2 to 6's, I did times 3. So that's going to be 3. All right. Now let's subtract, and we can do that since they have the same denominator. If I did 2 minus 3, I don't have enough, so I'm going to borrow. This is that fancy math. This is going to become 2 wholes, and then I'm going to put a whole 6 pieces with this 2, so this is going to become 8. 8 minus 3, that gives me 5. Leave the denominator 6, and then 2 minus 1 is 1. That's 1 5/6. Okay. Finding the value of x. I see x is talking about an angle measure, but I don't have any of the other angle measures. But wait, wait. Since it's equilateral, that means it's equiangular, and every single angle is going to measure 60 degrees. Okay, that stuff is coming back around. So I can say that 1.6x is equal to 60. Okay, because all the angles are the same. To get x by itself, I need to divide, and hey, look, another spicy meatball. Divide by 1.6, this gives me x, and oh, we got to do that ourselves. Dividing 60 by 1.6. Now, it's been a minute since we did decimal division. I don't like this decimal on the outside, so I move it over once, and whatever I do on the outside, I do on the inside as well. That decimal was there, and I move it over, add a 0 as a spacer. Go ahead and bring that decimal. Okay, so 16, it doesn't fit into 6, but it does go into 63 times. Again, pause if you need to, if I'm going too fast. That gives you 48. Subtract, subtract, subtract. You get 12. Bring down that 0. 100, let's see. I think it goes in 7 times. Let's do 16 times 7. That's going to give me 42. And 11. Yep, I don't think it's going to fit again, so 112. The difference there is 8. That's my new decimal, so I can add a 0, bring it down. 80, let's see. Let's go 5. I'm just guessing here. That's 30. Hey, look, I'm a lucky guesser. Okay, so x is equal to 37.5. Again, that's not the full measure of the angle because I would still have to multiply it by 1.6, but that is the value of x. Now, again, those were spicy. The next ones aren't as bad. So go ahead, try this you do over on the side, pause, and play when you're ready. Okay, it says find the value of y. Y is talking about this side length over here. Because it's equilateral, all the tick marks are the same. This 5y is going to be equal to that 25. So I can say 5y is equal to 25. To get y by itself, I need to divide. Cancel that out. Y is equal to 5. See, not as bad. I did the spicy one. Okay, find x. X is talking about this angle. Again, they left me hanging. They didn't give me any angles. But since it's equilateral, that means it's equiangular. That means all the angles equal 60. Okay? So that means that 4x is equal to the 60 degrees of the other one. Divide by 4, divide by 4. Let's go off to the side. 60 divided by 4. Maybe you know it off the top of your head, but let's pretend you don't. That gives me 2, 0, 5, 15. Okay? So, not too bad, not too bad. What I want you to do is you're going to go ahead and just partner practice with the evens, okay? Work through these highlighted even problems. Try to get a few problems under your belt, and then we'll come and check them, okay? Pause and play when you're ready. Okay, here we go. Number 2, again, pause if you need to look at that work. Number 4, it says hint, draw a picture. Number 6, this is only sometimes true. 8 and 10. Again, if you have questions on any of those and if your teacher can't get to you in time, please come to tutorials. Your homework is going to be odds, all the odd problems. Just as a reminder, you do have a minor ticket tomorrow, so make sure you're studying. It's on this triangle stuff. There might be a quizzes posted. They might have deleted it. I'm not sure, but if it is, it'll be posted on Canvas tonight. Thank you.